All right, functions and equations, 7.7. Function is a rule that relates to quantities. Okay, now, basically what a function deals with, input and output values. Okay, input and output values. The domain is the input values. The range is the output values. Okay, the domain is the input values and the range is the output values. Okay, now, for a function, you can construct an input-output table. Okay, you can construct an input-output table. All right, now, for your input-output table, it's going to look something like this. Looks something like that. Okay, and in it, you may have numbers like this: 1, 5, 2, 10, 3, 15, 4, 20, 5, 25. Okay, the X value is the input, the Y value is the output. Okay, so if that was true, if this table was a true function, okay, and we'll get into that here in a second, what makes a true function, what is not a true function. If that is a true function, what are you doing to each number? What are we doing to the inputs to get to the outputs? Tristan? Multiplying by 5. Okay, so we are multiplying by 5. Now, a function is expressed in the following form. Okay, all functions, if they are true functions, will be expressed as y equal something. Okay, in this case, it would be y equal 5 times x. Okay, be y equal 5 times x or 5x. Okay, this is the function of that input-output table that I gave you. Okay, so what they're basically saying is a function, it's like a box. Okay, in this box, is going certain numbers. And certain numbers are coming out of the box. Okay? We call these numbers going into the box input values, also known as the X values. We call the numbers coming out of the box the output values, and they're the Y values. Okay? Then something in here is going on. Okay? Something is happening to the numbers or the things that we're inputting into the box to have them come out in a different form. Okay? Now, what makes a function is the numbers that you plug in, the input values, always have to come out with the same output values for the same input value. For example, let's say I plug in a 1 right here. Let's say the first number that goes in the box is a 1. Okay? And it comes out on the other side, okay, as a 6. Okay, the second number I plug in is a 3. And it comes out on the other side as a 10. Okay? The next number I plug in is a 5. Okay, the number I come out with is 14. Okay, so something is happening to these numbers in here that's making the values come out, these numbers over here. For it to be a true function, if I plug 1 in here, then it would have to come out 6 again. It can't come out and be another number. So that's what describes a function. For every input, there must be exactly one output. Okay, so every time that I plug in a 1 right here, it comes out a 6 on the other side. If it doesn't, if I plug in a 1 and it comes out to be a 3, okay, then this can't be a function. Okay, so the first way we tell whether or not it's a function, we see if any of the input values are the same. If the input values are the same, then we look at their output value and see if it's the same. Okay, now, that is not to say that I can't do this. Draw a little smaller version. Okay, I have my inputs coming in here and my outputs going out there. That is not to say that it can't be this. I plug in a 1 and I get a 2. I plug in a 2 and I get a 2. I plug in a 3 and I get a 2. Okay, that can still be a function. Okay, because have I plugged in any other inputs that are the same yet? No. Now, if another 1 came up down here, then I would expect that it would be equal to 2. Okay? If it is, then that's a true function. Now, obviously, it's a little harder to figure out what you're doing here each time to get 2. Okay? It'd be easier if I had, if they were all coming out zeros, then you go, oh, okay, I know what you're doing. You're doing this. Okay? But let's go back up to our first box here. What is happening in here is called a function rule. Okay, what is happening inside the box to those input values to get the output values that we're looking at, okay, is called a function rule. Directions will say sometimes list the function of the input-output table, or it'll say list the function rule of the input-output table. Both mean the same thing. Okay? The function, or what is happening to that number here, is a little difficult. All right? It's a two-step function. In other words, we're not just adding something to it. We're not just multiplying something to it. We're doing two different things to it. When you have that, and it would probably clear this up if I said this. If I plug in 0 right here, and it comes out 4. Okay? So I plug in 0, and it comes out 4. All right? Now, let's see if we can figure out what the function rule is for this. Okay? So if I plugged in 0, and it came out a 4, what did you have to 0 to make it 4? What did you have to do mathematically? Nicole? Add 4. So I know that in my function rule, it's going to be y equal something and adding 4. Okay, because remember, there's an x right here. Okay, there's an x right there. So if I plug in a 0 right here, if I plug in a 0 right here, y equals 0 plus 4. Okay, does y equal 4? If I have 0 plus 4, the next statement would be y equal 4. Now I'm going to erase this so I can have more room. Okay, so let's check to see if the next one is true. My next input value is 1. So if we say y equal x plus 4, and I say y equal 1 plus 4, that means y is equal to 5. Well, is that 5 equal to 6? No. So I can't say that it's y equal x plus 4. There's something else going on besides just adding 4. Okay? Well, right here, the only way that I can get a 0 or continue to get a 0 is either to multiply or divide it by a number. Right? 3 times 0 would be what? 3 times 0 would be what? 0. Okay? 0 divided by 3 would be what? 0. So, the only way that I can come up with a 0 in this part of the function, okay, is to either multiply the x or divide the x by a number. Okay? Now, if I look at the difference between 4 and 6, how much is different there? 2. Okay? So, if I'm going to multiply 1 by some number, or I'm going to divide 1 by some number, I would have to get a 2, right, in this little blank area. In other words, that has to equal 2 when x is equal to 1. Okay, so I've got to multiply this x right here by some number, or I've got to divide it by some number. Well, can I divide 1? Okay, let's think about this. Can I divide 1 by a number like, let's say, 2? Okay, but is that going to give me a whole number? No, that's a proper fraction. And if I keep dividing by numbers, is my number getting larger or smaller? Smaller. Okay, so I can't be dividing because there's no way I can divide something into 1 and get 2. Okay, so that means I've got to be multiplying. So I've got to multiply 1 by something to get 2. What would that be? What do you multiply 1 by to get 2? 2. So what I think then is my function is this. I'm taking y, and that's equal to 2 times my input value, x, plus 4 more. Okay? So let's test that. How we test it is we simply plug in our values that are in our little box up there. So let's look at 3. So y equal 2 times 3 plus 4. Well, 2 times 3 is what? 6. So y is equal to 6 plus 4, which means y is equal to what? 10. Okay? So y is equal to 10. So let's check it. 3 was here, 10 was there. So that is true. That is a true statement for that input and output value. Let's try the last one, 5. So I plug in y equal 2 times 5 plus 6. Well, what is 2 plus 5? Or 2 times 5? 10. Plus 6. 16. Y is equal to 16. Okay?
Shouldn't it be plus 4 though?
Oh, excuse me. Yes, thank you. My bad. Yeah, back that up. So 14. So that is correct. 5 here, 14 there. Okay, Nicole.
I'm confused. Say about the y equals 2x plus 1.
Okay. Which part are you confused on?
On like the 2x. I'm confused.
Okay, we'll look at another one and hopefully it'll clear it up a little bit for you. Okay? But your answers, when they want the function or the function rule, your answers are always in y equal, then there's an x. Okay? Now, that x can be by itself. That x could be being multiplied by. Okay? That x could be divided by. Or that x could just stay by itself and then you add or subtract to it. Okay? So we're taking the x, which is the input value, and we're doing something to it. Most of the time, there's only going to be one thing that you're doing something to. Okay? Other times, there may be two things, like in this one. This is one of the hardest types of problems that you'll have to deal with this year. Okay? Most of your ones you're going to be dealing with. Let me give you another example. Let's do another input-output table. Okay, and this is how it's done in the book. Okay, they're going to give you this table. This is actually one of the problems. They're going to put those values in there, and then they're going to put these values. Okay? And so what they're saying is this. I've got a box. Okay? In this box, the numbers 2, 3, 4, and 5 are going into the box. Okay? They're coming out of the box as a new number, 0.8, 1.8, 2.8, and 3.8. That's what these numbers are coming out of the box. So something is being done to the 2. It's going into the box, and the 2's coming out a 0.8. Okay? So obviously, am I adding something to 2? In other words, when it went into the box, it came out 0.8. Did the number increase or decrease? Decreased. So the only way that we can decrease a number is to do one of two things. Subtract or divide. Okay? Now, if we divided, well, now we got to figure out, okay, what did we do to 2 to make it 0.8? Okay? They're not going to give you ones that complicated this time. Okay? They're not going to give you ones where you're having to divide by decimals or fractions or things of that nature. Now, you will have to divide some of them, but it'll be dividing by a whole number. Okay? So, if I was to subtract, what did you do to 2 What did you subtract by to make 2.8? Well, to figure that out, we simply do this. What is 2 minus 0.8? So what is that? 1.2. So, for me to get 0.8, okay, then that means I would be subtracting 1.2 from the input value. Let's try that. So my rule that I think is happening, here's what I think is happening inside the box. So that's y equal taking my x value and subtracting 1.2 from it. That's what I think is happening. Okay? Now I have to test it. I have to test to make sure that is what truly is happening. So to test it, I'm going to take my next input value of 3, and I'm going to say y equal 3 minus 1.2. So if I had $3 and I take $1.20 from it, what do I have left? $1.80, which is 1.8, correct? So that is y equal 1.8. So that one checks. Well, just to make sure, I'm going to check one more. Y equal 4 minus 1.2. What is 4 minus 1.2? $2.8. So that one checks. Okay, so my function then is that rule right there. Y equals, so the answer to this problem, okay, the solution to this problem is y equal x minus 1.2. That's the answer. That's the function that is represented by that table. Okay, that's the function that we have. Okay, now, I want to put a table up here and I want you to try it on your own. The x always has to go first in a function. It's always y equal whatever I'm doing to x, and then plus or minus if there's anything left. Okay? Sometimes there's not. If you're just multiplying or dividing, then your answer is going to look like this. If you're just multiplying or dividing, it'll be y equal like 3 times x. Okay? Or 4 times x, or 5 times x, or 6 times x. If you're dividing, let's say I was dividing by 2, it would look like this. Okay? If I was dividing by 3, okay, that would be the function for dividing by 3. Okay? So, let me give you this one. And let's try it. Here's my input-output table. Usually when they have 0 in them, it makes it a little bit easier to do. All right, so there's your input-output table. So you're going to have an answer, y equal something. Okay, so see if you can figure out what's going on. If my input's -3, it becomes a 1. My input is 0, it stays a 0. My input is 3, becomes a -1. My input is 6, my output is -2. Okay, see if you can figure out what's going on with those. When you think you have the answer, raise your hand. See a lot of blank stares out there. Nicole, you think you have an answer? What do you think the answer is?
Y equals X divided by
Negative what? Yep, that is correct. Okay. Now, the function rule is y equal x divided by negative 3. Okay. Here's how we come up with that. Okay. We have an input of negative 3. Okay, so I'm plugging negative 3 into the box, and it's coming out a 1. So, it went in a negative 3, and it came out a 1. Well, I reduced, or the number got smaller. The input value got smaller when it went into the box. Okay, now, did it really get smaller? Well, it got smaller in the sense of I went from a 3 to a 1. We know that negative 3 is actually smaller than 1. Okay? But we reduced the absolute value of the number. We took it from a digit of 3 to a digit of 1. Now, the only way that I can do that is to go from negative 3 to a positive 1 is one of two things. Okay? I either have to subtract or divide. Okay? I either have to subtract or I have to divide. Now, to subtract it, for me to get a positive 1, I would have to do this. Negative 3 minus 4. That's the only way that I could get a positive 1. By subtracting. Okay? Actually, hang on here, it's negative. Subtracted negative 4. Okay, I could add 4. You could have this, like that, and that would equal 1. Okay? Now, here's why I said when they give you a 0, it helps you out. Well, if I take 0, let's just plug it in. I'll just write it down right underneath it. If I take 0 minus negative 4, or 0 plus 4, is that going to equal 0 on both of those? Is 0 minus negative 4 going to equal 0? No, it's not. Okay, it's going to equal 4. Is 0 plus 4 going to equal 0? No, it's going to equal 4. So therefore, that subtraction can't be the answer. I'm not subtracting those input values and getting the output values because right here it says I plug in a 0 and I get a 0 out. Okay, so obviously I didn't add or subtract to it. Because if you add or subtract a 0, you're just going to get that number that you added or subtracted to it. Okay, so that means I must have divided. Because when I divide something into 0, it gives me 0. Okay, so since I am dividing, what do you have to divide into negative 3? What do I divide into negative 3 where it's going to equal 1? Well, if I divide 3 into 3, I get 1. Okay? If I divide 3 into negative 3, I would get a negative 1. So I know it can't be that. So in other words, 3 goes there. It gives me -1. If I plug in a -3, -3 into -3 gives me a +1. Okay, so let's see if that's true for all of them. So what we think our answer is y equal x divided by -3. Okay, well, we already know that if I divide -3 into -3, in other words, if I have this right here, that's going to be +1. I also know that if I do this, that's going to be equal to 0. So I know those two are correct. So that's 2 of the 4 that I have in my table. Okay? The next one I had in my table was a +3. Is that correct?
Yes.
Okay? So if I take y is equal to 3 divided by -3, is that correct? Well, that's y equal -1. Well, is that the output you got for 3 in our table? In other words, back up here, 3, -1. So yeah, so all 3 of these checked out. So I don't have to check the 4th one. If I check 3 of the 4 and 3 of the 4 are correct, then my answer that I came up with is correct. Okay? Now, that's the hardest part of this. Was that right there? Is getting an input-output table and giving the function rule for it. Okay? Let's look at something a little simpler in the process that we've got to do today. Okay? I give you this function, y equal x plus 11. And I tell you that the domain, remember, what is our domain? What does that represent? Inputs or outputs? Inputs, okay? I tell you that our domain is -2, -1, 0, 1, 2. Okay? And they want you to make an input-output table. So all they want you to do is do this. I know, school stinks, doesn't it? Oh. All right, so what they want you to do is take those domain numbers and put them up here, -2, -1, 0, 1, 2. They want you to take those input numbers and they want you to plug them in to our function of y equal x plus 11. So they want you to do this. Y equal, take that -2 and plug it into the x. So -2 plus 11. What is -2 plus 11? 9. Y is equal to 9. Because you have a negative and a positive, you subtract their absolute values. Okay? So that would be 9. Then they want you to take and do the same thing for each one of the numbers. Y equal -1 plus 11. What? 10. Okay? Y equals 0 plus 11. 11. So what's the next one going to be? 12 and 13. Okay? So you can figure out the pattern. I mean, it's just basically a pattern. Now, here's the key, though. You got to make sure that your input values follow the same pattern. Okay? -1, -2, -1, 0, they go up by 1. A while ago, we went with 1, 3, 5. Okay? Those were a pattern. If it was to go -2, -1, 10, 12, 14. Okay, well, obviously the first two would not be in a pattern. Last three were, okay, but there's got to be a pattern here for it to keep doing the same pattern down there. All right, now, let me show you one that's not a function. Let me show you what one looks like that is not a function. Here we go. They give you this table. They say the input is S and the output is T. Okay? And then inside they give you this. 1, 1, 4, 4. And the output is -1, 1, -2, 2. Okay? That's what I said. So, this, you plug in a 1 there and you get a -1. Then they plugged in a 1 here and they got a +1. Okay? So this is not a function. That's your answer. Not a function. Okay? Now, when they give you one like this, and they say the input is P, the output is Q, and they give us -1, 0, 1, 2, and they say 1, 0, 1, 4. Okay, first of all, is that a function? Well, do they give us any repeat input values? No. So we have to assume it is. Because they didn't give us another -1, they didn't give us another 0, they didn't give us 1, or they didn't give us 2. So we have to assume that if these numbers popped up again, they would have the same outputs. Okay? So if they don't give you a repeat input value, it's automatically a function. You have to assume it is. Okay? Now, what do you do to -1 to make it a +1? Let's go to 0. 0 and 0. So am I adding or subtracting anything to these numbers? No. I'm not. Because if I was, that 0 would have to be something other than 0. So what do I do to -1 to make it a +1? I can multiply. What do you multiply -1 by to get +1? -1. -1 times -1 is 1. Well, if I take -1 times +1, do I get a +1? If I take -1 times +1, no. Okay, so what do I do to this to make it 1? 1. What do I do to 2 to make it 4? 2. Okay, let's go back here. So we said here, if I take a -1 times -1, I get +1. If I take +1 times 1, I get +1. If I take 2 times 2, I get the 4. So what is my pattern? What is my rule? No, I just told you. What am I multiplying by? No. No. Let's think again. What did I multiply this number to get this number? And what is that number? Okay. What did I do to this number to get the 1? There you go. You're multiplying the number, the input value, by itself. So here's how you would write that. Yes, it is. Y equal x times x, which is y equal x squared. That is a function because you are doing the same thing in the box. You're multiplying whatever comes into the box by itself. Okay? So that is yes. That is a yes and a function. Your homework is 7.7, 1 through 26. And we've done quite a few of those. Okay? Due tomorrow. Okay? Hadn't had homework in a while, so let's make sure we get it done.